Heron. I'm the KTT lead for the Alberta Agrisystems Living Lab. And I'd like to take a minute to acknowledge that the members of the Alberta Agrisystems Living Lab team are grateful to live, work, and be in relation with people from across many traditional territories across Alberta. This acknowledgement is to reaffirm our commitment and our responsibility to improving relationships and our own understanding of local Indigenous peoples, their cultures, and their knowledge. I'm very excited this evening to introduce Dr. Vern from Agriculture and Agri-Food Canada at Lacombe and Dr. Erick Santos from the University of Alberta in Edmonton, Alberta. They're going to join us tonight to talk about adding annuals to your grazing plan. And so if anyone has any questions for Dr. Vern or Dr. Santos, please put them in the webinar chat or in the Q&A, and we will answer them after their chat. And so with that, I'm going to turn it over to Dr. Vern. Take it away, Vern.
Thank you, Adrian. And because this is one of the first webinars I've had on this series, just ask Adrian to let me know if everybody can hear me. And that's the first good thing. So yes, we're going to be talking about adding annuals to your grazing plan this evening. And Erick Santos from the University of Alberta and me, Vern from AAFC Lacombe, are looking forward to talking to you about annual forages. I've worked on them for about 30 years, and Erick has been in Alberta for a little less time, but he is really excited about some of the work he has on the go. In addition to that, I'd like to thank some collaboration from Dr. Emma McGough from University of Manitoba. We've had some conversations with her. She has some projects that are similar. And so we hope that we can spread our knowledge a little bit more broader than just Alberta. We also have had input from Susan Heather, who is a farmer and consultant from the Vulcan area, west of Vulcan actually. And she may be available to give some answers to questions you might have about some of the work that we'll present on her Living Lab project. So the first thing that we want to say, and this is going to be the first thing and the last thing that we say, is that annual forages have to fit within a perennial forage beef system. And we know that that system varies by ecozone or the climate and the location where you come from. And so what you might do or management practices that you choose could be different from what we would have in central Alberta, for example. So the first question is, what happened to the perennial feed source and the land that it was grown on anyway? Because it's a bit informative about where we have to go with annual forages. So the short story is that tame hay pasture and the most productive side of the hay and pasture area, alfalfa and alfalfa mixtures, the area or the number of acres that we have to grow in Canada has declined a great deal. And you can see from this slide that tame hay in particular declined from 20 million acres in 2006 when we had mad cow disease down to 13 million acres. So not quite 50%, but that's a long way to drop. And part of that is because cow herd number has dropped as well. That there are dynamics that we'll talk about. Cow herd number versus acres of feed that fit into where we could be going with annual forages. So you can also see that tame pasture is reduced considerably, and the same with the highly productive alfalfa and alfalfa mixtures. They declined because they were probably on the better land, and that land went into crop production. So along with that, what we know is that as acres increase with cow herd number, the carbon sink or the carbon dioxide sink that offsets greenhouse gas emission is growing. And when we have less acres or less new stands being put in the ground, we're losing soil carbon, and then the sink becomes a source. So we did lose that capability. If this turns around, we're back into the cycle of having a stronger sink. So we talked about 2005 to 2021. And in the most recent years, in this slide, you can see where the acres were lost in the recent decade and a half, so to speak. And so the red dots show where we lost forage acres over that period of time. And you can see from the red dots, we lost about a lot of pasture acres in eastern Alberta and along the semi-arid border between Alberta and Saskatchewan. We also continued to lose hay acres. What happened to cow number? Well, it's well known that since 2006, the cow herd has declined, as I said, and with it, the acres of forage. But what it appears to have happened is that the forage acres, or the ratio of forage acres to the cow number, decreased faster. Forage acres decreased faster, so that in Alberta terms, in 2015, we had more acres per cow than we do now. So if we look at this in terms of what we're told in the old days and even now, we have to have extra forage on hand for times of drought and so on and so forth, feed deficits from year to year. That isn't quite as easy to do now as possible. So annual forages kind of helps fill that gap. Usually we get these numbers and estimates on a province to province basis, but I thought it was interesting to look at this from ecozone basis. So here we have the soils map, basically gray wooded soils, black soils, and brown soils. But if we look at it in terms of ecosystems, we have three main ecosystems, which are ecozones, which occupy 80% of the cow herd in the prairies. So the prairies themselves have 80% of the cow herd in Canada, but these three ecozones have 80% of what's in the prairies. So we have the central boreal plains, which is gray wooded soils, low in nitrogen, but adequate rainfall. We have the black soils, which are kind of the best of the best. And then the semi-arid area, which is large and often quite dry. So what happened to those with respect to forage loss and cow loss or gain? So what I did was I looked at these areas by cow number and by forage acres. And the acres were split into rangeland or unimproved pasture, tame pasture, and hay. So as we go from 2011 to 2016, the hay area in the boreal plains, or the northern part, and the parkland decreased about 20%, about 20% over about 5 years, and about 15% in the central plains or the semi-arid area. The tame pasture also decreased about 9% in the parkland and the central plains. So that was the big thing. Rangeland decreased about 4% in the parkland and the boreal plain. And interestingly enough, in the central plains or semi-arid area, it decreased 6%. All those losses could be interesting, but what's most interesting is while the rest of the prairies decreased in cow number, the parkland and the central plains increased in cow number, which made the ratio much smaller than it had been 10 years previously. And I believe that this relationship continues, and one has to wonder where the extra feed will come from, and kind of explains why feed costs are so high in years of drought. Some of that hayland that went out probably has gone into occasional annual forage. So that's a bigger picture across the prairies about why we're interested in annual forages, but also within the season, what we grow for forage and how we plant it has to fit within the framework of the cow reproductive year. So at the Lacombe Research Station and in many areas across Western Canada, we've learned over the past 30 years that once cows are weaned and go into the early part of winter, their nutritional requirement is quite low. And at that point, they can winter graze and maintain themselves quite well on high yielding, lower quality forage. It's what we try to do with swath grazing and corn grazing and so on. In more recent times, we've been hit by really hot, dry weather in the July period, and that reduces growth of the cool season grasses that both Erick and I will talk about, and sometimes requires feeding on pasture. So those are things we want to avoid. And we could add another part in the March, April, May period. We know that we're not growing much in March, but in April and May, because cows are lactating heavily with new calves, their nutrient requirement is high, and any way that we can offset feed requirements at that time is quite useful. This is a very brief idea for you of what it costs for various methods of extended grazing. Now, I got this from the production economics people from the Manitoba Agriculture. They put out a nice spreadsheet every year with this kind of information in it. We calculate those ourselves, but I use these because they're quite current, and there's one out for projections for 2026. Projections for 2026 and total cost of winter feeding, which is not on here, is about $4.50 a day. If we extend grazing, keep cows on pasture longer after the perennial season is over, we can look at reducing that cost considerably to even more than 50%. So these are Manitoba numbers. They're not the numbers that we would find perhaps in central Alberta. The corn grazing cost is about right, costs about twice as much to grow corn than barley. So corn has to be really, really high yielding. In Manitoba, they've had problems with plant diseases, so barley yields aren't as high as central Alberta. So we would see in central Alberta our barley grazing costs at least down around what is shown for corn here. The target in Manitoba was 35 days for grazing, swath grazing. We would want to have our target for swath grazing up around 100 days, and the same for corn grazing. Stockpile grass is probably the cheapest, but because it yields less, the carrying capacity is usually about a third of what it would be from the two examples above that. And of course, the cheapest is to graze stubble after combining. So the strategy has been to stretch out the grazing season as much as possible so that we can get that daily cost of grazing below what it would cost in a feedlot or a feeding site. In the different provinces and different ecozones, we have different total number of days of winter feeding. In that Central Plains area, probably there is the least winter grazing and the most dependent on extending the grazing one way or another. Why we have issues with the perennials and stockpiling are issues with drought, high and low temperature, and dormancy that reduce the potential to stockpile. So we need something to replace that. Climate is changing, we believe, and we see climate being hugely dynamic, dry springs, hot summers, too much rain, not enough rain, within short distances. And so as climate change, how we manage it impacts how we manage crops and livestock. And so we have to move to new systems. So for example, let's just use a couple of climatic problems that we have to deal with. In the most recent times, with dry springs and hot summers, all grass pastures tend to grow dormant. Species like bluegrass, brumgrass, and quackgrass go dormant, often because of shallow root systems. Also, the fact that once you get over 30 degrees for a number of days, those C4 cool or C3 cool season species just can't handle the temperature, and they automatically go dormant to survive. We have used at the Lacombe Research Station, and because of work we've done here, winter cereals planted in the spring to offset this period of time. It isn't the only way that we can attack this problem, and Erick will have a few ideas that he will talk about. So we would depend on the cool season grasses or the grass type pastures, maybe grass alfalfa pastures, throughout June, early July, and then in the hot part of July, we may move to a ratio of about 3 paddocks of winter cereals to 1 paddock of the cool season grass. And that gets us by. A summary of the impacts of climate and dormancy on the perennials kind of looks like this picture. If we can keep our perennial systems in a good, healthy mixture of grass and legume, relatively youthful stands, they should be deep-rooted and should be quite vigorous in growth, and they can withstand some of these climatic pressures a bit longer. Older stands, as they accumulate species that we really don't want, like Kentucky bluegrass, and we lose alfalfa or legumes simply because of winter kill or overgrazing, can't handle a situation. And as we get into this late July, August, September period, we may have to look at other methods and species or different paddocks, growing other species to take their place. Why is this a problem? Well, it's an impact of soil moisture. And if we talk about this in very simple terms, there's a trajectory of soil moisture decreasing as we go through the spring until the fall. So if Erick asked one of his students a question, or his whole class a question about how much water is there in a meter of pasture in August in Alberta, if the smart guy at the back of the room said nothing, yuck, 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 you'd have to give him a red star, because he'd be pretty much right. So there's a trajectory in the perennial stands of moisture declining, and that happens because the time when we can depend on grass stands to have a full profile of soil moisture is right in the spring. As soon as the perennial grass on our green line here begins to green up, it starts to evapotranspirate, and water is lost through the leaves until, and as soon as the full canopy is on the crop, it continues to transpire rapidly. And so bare soil doesn't lose water quite as fast or nearly as fast. Because we plant the annuals in May at some point, we don't develop a full canopy probably until mid-June. And so it's not that we're more efficient in water use, we're just simply saving that water in the soil for use later. And there's sort of an offsetting situation going on. During the time when we're growing with a full canopy, growing at a fast rate, we're using water. After we graze, we're reducing the leaf canopy, and so that also reduces the loss. So we may actually pick up some soil moisture if it rains. But when all these perennial or annual canopies are growing at a rapid rate, they are using moisture. And so, to a certain extent, we have to think about this in developing our strategy. When it's very hot, over 30 degrees, most of the species that we know of are not growing much at all unless they can attain some water and have a higher, better tolerance to high temperatures.
Okay, so why and when to use these annual forages? And Vern did cover some of these aspects, and I want to point that these are not all of the reasons why we want to use annual forages, but they are for for sure very important. The first reason I have here is like to fill seasonal gaps. Okay, so we can use annual forages to fill seasonal gaps in early spring. We can fill that gap in the fall as well, but we can also fill that gap in something that we call summer slump, which I'm gonna cover in a little bit. One of the main reasons why we use annual forages is to extend the grazing season and reduce feeding costs, as Vern was showing some numbers before. Also, especially in that hot and dry scenario, we have some annual forages that would be adapted to drought, okay, and they would be more heat tolerant as well compared to the forages that we usually use, compared to the some of the perennials that we have. And whenever we are thinking about those polycrops or crop blends that we are mixing brassicas and sometimes chicory and plantain to the mix, many of the times we are thinking about improving some aspects in the soil, and also improving the animal diet as well. Okay, so and here, so we put this slide together, and it's basically again going back to our first point is that our annual forage system, it needs to fit our perennial forage system. Okay, so we're gonna do the annual forages to complement, um, to to basically we need to integrate that annual forage system into our perennial forage system. Okay, so let's start in looking to this picture using the two gray boxes. So we have one dark gray box, which is the grazing on perennials. So this is the most likely scenario that we can graze from June to September. And then we have this light grazing on perennials. Um, so these are light gray on grazing on perennials, which would be from May up to October. Okay. So and how can we complement those systems? How can we support those systems using annual forages? We can use spring seeded winter cereals. Okay, from June to potentially November. We can also use the fall seeded winter cereals early in spring. During this time of the year, usually the perennial forages they are still dormant. Okay, so what happens here is that the cereals they are usually earlier than the perennial forages. We can have the option to utilize some of this summer C4 annuals as well, and I'm gonna discuss a little bit about that. And of course, as you're familiar with other methods to extend the grazing season, we have corn grazing and swamp grazing that could start in November, and perhaps if you're lucky, we could have that going on until February, for example. And as well, we have the biograzing system. Of course, the biograzing is going to be on mostly on perennial forages. Um, so going back to that summer slump, so we have two graphs here. So let's pay attention first in the graph A. Okay, so we have a typical pattern of a cool season grass growth, where we have a spring peak, we have a summer slump, and then we have the fall peak. So during the spring peak, we're gonna have like the maximum of production. But during this time of the year, what's gonna happen? So we have like a lot of light intensity. So the plants they will start maturing, and once some of the plants starts going to the reproductive stage, we're gonna have something that we call apical dominance. And after that apical dominance, many of the tillers they will stop growing. Okay, so the plants basically gonna send signals to the other tillers to stop growing vegetatively. So we have this summer slump going on, especially if we have very dry and hot conditions. That slump can be even higher. And then once that release from the apical dominance occurs, we have a second growth, a second peak during the fall. Okay. However, this peak is going to be much smaller because the plants, they need to store energy to perenniate through the winter, and also we don't have as much tillering going on since they don't have to go through the reproductive stage anymore during this time. And then if we go to the other figure and we see like a typical pattern of growth from a summer annual, we can basically see that they will produce a lot of biomass during summer, and we could utilize that biomass to potentially support grazing during the summer slump, or potentially stockpile this growth and utilize later in the season, in early fall, for example. Can I go to the next? Okay, so we are doing a study here at the University of Alberta. That's in the South Campus in the Black Soil Zone, and we're evaluating two warm season grasses. Okay, so we have Sorghum Sudan and we have the red proso millet, and we're evaluating these two warm season grasses in association with sun hemp, which is a warm season annual tropical legume. So sun hemp grows very fast and grows very tall, and it's a very good combination to grow together with sorghum and millet. Okay, so we have tested that before in other regions. Okay, and it works. So now we are testing sun hemp in combination with sorghum here in Alberta to see what the results are gonna be. And we go next. And we actually do have some preliminary results to show. Okay, so I'm gonna go into detail into this picture. So I think we are not seeing everything in the picture, but basically we have two harvest frequencies here. So the dark column, it's in August, and the light color here, it's in October after the killing frost. Okay, so we did harvest early in the season, and then the ones that we harvest later in the season, they are other plots. Okay, so not the same plot. And we can see here, first things that the more we wait, the more biomass we can use later in the season. So we could potentially stockpile that forage and utilize in early fall. Okay. We could do some summer grazing. We would get a better nutritive value, but however, the biomass would be compromised. I don't have the nutritive value to show yet. We only analyze it from August. But if you look to the leaf stem ratio, we can see that the leaf stem ratio is going to decrease from August to October. Okay, and if we have that decrease in leaf stem ratio, that means that our crude protein will be declining, our fiber will be increasing. So overall, we would have a better nutritive value early in the season, but that would come at the cost of losing production. And what happened to the sorghum? So we can go to the next one. What happened to the sorghum? So for the sorghum Sudan hemp mix, we had a similar response. Okay, so we can see here we have the sorghum Sudan in monocrop, sorghum Sudan plus nitrogen, sorghum Sudan plus sun hemp, and sorghum Sudan plus sun hemp. So we had two cultivars of sun hemp, and overall, growing monoculture was better for the sorghum. Okay. However, in the early season, whenever we did the harvest in September, we can see that sorghum Sudan control without nitrogen was comparable to sorghum Sudan plus one of the sun hemp cultivars. However, the main message here is that, well, if we wait until the killing frost, okay, until October, okay, from September to October, so it was not like a very long time interval between those two harvests, we could get 5,000 more kilograms per hectare of dry matter. Okay, so in summary, what I'm telling you here is that those warm season C4 grasses, they will yield a lot, and of course they are more adapted to hot and dry conditions. So perhaps in the south of the province they would even do better. And similar to what happened to the millet, the nutritive value will decline as the more we wait to harvest them. We can go to the next. So here I'm just showing like whenever they did reach the 95% light interception. So by August 5, we had the sorghum control and sorghum nitrogen reaching that 95%. light interception. And by mid-August, all of the treatments had reached that light interception. And this is very important because it's usually whenever the plants have the canopy closure, they are uh, more efficient doing photosynthesis, okay? Because now they can intercept the more light possible. And we also have a very nice intersection between forage productivity, production rate, and the nutritive value, okay? So that was reached in mid-August. And now switching a little bit to another concept. So we are investigating many different combinations of species and growing them together and evaluating how harvest also influences the nutritive value and production. So we have this multiple species trial. We can call it polycrops and cover crops trial, cocktail blend trial. So basically, we're investigating the role of functional groups and number of species in various forage parameters. And we do have 5 different functional groups, okay? So basically, a functional group, plants in a functional group, they will play similar ecological roles, okay? They will have very similar environmental roles that they will perform. For example, we have these 3 here. We have cereals. So the main function for the cereals in a blend would be to provide biomass, structure, fiber. We have legumes. Legumes, you usually add legumes to those blends because they would increase the crude protein of the blend, and also because of their ability to fix nitrogen from the atmosphere. We have brassicas that can help with nutrient cycling, nutrient scavenging. They can help with decreasing the soil bulk density. We also have these 2 other groups here, pasture herbs and fodder herbs. So these are a little bit more subjective functional groups, but we did divide this way. And for example, we could add those special herbs to improve nutrient cycling and also improve the nutritive value of the diet. And we added that floral herbs group to basically attract pollinators and increase biodiversity. But of course, they will provide fiber as well. So the setup we had, if you look to treatment 1 to 10, so it's a lot of treatments, okay? But basically, we are increasing the number of species and number of functional groups. For example, treatment 1, we just have 1 species. In this case, it's oats from the functional group cereals. And then if we go to treatment 10, all the way to treatment 10, we're going to have 5 functional groups and 10 species, okay? So we had many different blends. We can go to the next. And of course, I'm not gonna talk to you about every single treatment difference, but I did compile the data in other ways that it's easier to understand. And here we have the biomass production by number of species. Okay, so we are increasing from 1 to 10 species. Okay, it's not 1, 2, 3, 4, 5, 6, 7. Okay, so we have 1, 2, 3, 4, 5, 6, 8, and 10 species. Okay, but the summary is that, so we start with only 1 cereal here on the left, and then as we go to the right, we have all the functional groups and all the species there. So in the first set of columns, we did harvest in July, and then we harvested again the regrowth in September. In the second set of columns, we only did the harvest in September. And we can see that there is a trend here of, so basically A is good, and if they have the same letter, they are not different, okay? But we can see that there is a trend. As we increase the number of species, we can potentially decrease the biomass production in the first set of columns. But we do have some cases here, some caveats here, that whenever we increase the number of species, we can have a comparable production to the biomass of the monoculture crop. I want to call attention here, for example, for these 60 species. In this case, we had 2 brassicas, 2 legumes, and 2 cereals, and they had a comparable production to the treatment number 1, just 1 species. And especially if we wait until the end of the season, some of the treatments that included brassicas, for example, and chicory and plantain, they kind of hold it, the production very well, okay? We can go to the next one. So if that was still a little complicated, I also did compile the data by functional groups, okay? So here in the first column, we have just cereals. And then in the last column, we would have 5 functional groups, okay? So if we see here, there's a trend. So as we start increasing the number of functional groups, there's going to be a decrease in biomass production. Okay, so just having oats and barley will yield more most of the times, especially in this case. However, there are other benefits that we can attain by mixing those crops. Can we go to the other slide, please? So I thought it would be a good idea to bring to you some of the botanical composition data. This is only for the plots that were harvested in July and again in September. Let's pay attention in July first, okay? So in July, so pretty much the first 2 columns, they were only grasses, okay? So oats and then oats and barley. But overall, we had oats in every single treatment and sometimes barley was present. But overall, usually the grasses, they comprised about 70% or more of the botanical composition. We had peas, especially before harvesting in July. We had peas with a good percentage, and then we had some herb veg. We had turnips showing up. Okay, so but basically, by July, the grasses and some and at some content legumes as well, they were dominating the mixes. However, after we did harvest and we harvest again the regrowth, we can see that the treatments that were mostly dominated by grasses here and grasses and legumes, okay, because the grasses and legumes, they usually they were die or they mature and they did not come back as well in the second harvest. We can see that the plots that we only had grasses and grass and legumes pretty much they had a greater percentage of weeds. Okay, so this red cycle, it's pretty much indicating the weeds presence. And we can see that in treatments, for example, 5, 6, 7, 8, 9, and 10. So we can see that this purple, it's turnip. Okay, so it's a brassica. So we can see that there is an increase in turnip, there's an increase in chicory, there's an increase in plantain after we go there and evaluate the regrowth. So basically, after we harvest, these other plants, they have opportunity to grow again. Can we go to the next slide? I just want to make a point to the other slide. Those were only proportions, okay? It's not related to, it is somewhat related to the production, but it could be like a proportion of 1,000 kilograms per hectare. And here, so another reason why we want to mix, if we look to the crude protein by the number of functional groups, we can see that having cereals, legumes, and brassicas resulted in a greater crude protein than cereals only. And also we had a lower neutral detergent fiber happening for that treatment with cereals, legumes, and brassicas. Okay, so we could have an improvement in the nutritive value by having these mixes, and especially if we have incorporated herbs. So if we go to the group containing 4 or 5 functional groups, both of them will have herbs, and the other one will have herbs and floral herbs. So we can see that the neutral detergent fiber will be a little higher compared to the brassicas. So and the next one, and I think that's gonna, yeah, okay, thank you.
That was very interesting, Erick. Um, so one of the things that producers like to do is to increase their yields of annual forages in the spring and the fall for the reasons that we talked about previously. So we've been working on different ways of using winter cereals and different kinds and species of winter cereals to graze in the summer and fall and perhaps the spring. And we find that we have to seed at different times of the year. And producers tend to come up with different ideas of using these things. And of course, one far out idea is to be able to use the winter cereals for several years, even though that's likely not realistic. So there are risks associated with earlier than recommended planting dates, and the recommended planting dates for grain for most of those winter cereals across the prairies spans about 2 weeks around the 1st of September. So that would be the ideal for grain production. But the problem we have is that we don't really get much forage production in this cool, dry climate that we have if we plant at the same time for grain production. But there are risks associated with earlier than recommended planting date, and that usually results in some winter kill. So the risks of planting and early grazing and growing in mixtures with winter cereals increase the risk of winter kill or survival till the next spring, because we need a certain quantity of plants that come through the winter to provide the canopy for photosynthesis in the spring and for growth in the summer. And if the plants winter kill or are weakened, they just aren't sufficient. So we don't necessarily recommend that they will make it. Sometimes they do. So just to give you an idea of how early we have to go, to provide grazing, say, from July through until the fall, we found that we can plant in late May. And if we look at the yields of the pasture from spring until fall, that's when we get the highest yield. But we have the flexibility of planting anytime we want. To give you an idea of the cost of pasture, now we talked a little bit about that right at the beginning, but the cheapest pasture you could get in the middle of the summer would be usually community pastures or large pastures operated commercially that people can send their cattle to. And the cost of this might be anywhere from about 85 cents per cow day up to maybe $1.25, depending on bulls and fencing and so on and so forth. So a winter cereal pasture, or basically any cereal pasture, a simple mixture compared to what Erick was talking about, depending on how much infrastructure, which means fencing and water and so on, is probably going to cost between $1.50 and $2 a day. And I will say yield is really important, because yield translates into carrying capacity, and the higher the carrying capacity will be, the cheaper your daily costs. So hay or silage, by comparison, if you got caught because of drought in the middle of the summer, you simply run out of pasture somewhere between $3 and $5 a day. So here is a picture or example of how we used winter triticale planted in May, and then grazing perennials in June, and then switching to triticale for a period of time, 2 to 6 weeks during the summer, and then again in the fall. We've also grazed during September, after having planted swath grazing ground, to a winter cereal in the middle of July. That's getting a little late, but planting in the middle of July can still give you enough moisture and enough growth to be grazing in September and October. So in one piece of work that we looked at, we had several winter cereals, and I'm only going to use hybrid rye as an example, but we overseeded some of the paddocks to oats over the winter cereals, or peas over the winter cereals. And this is an example of the oats being planted over hybrid rye. On its own, in a monocrop, hybrid rye did quite well in terms of its rate of production and total production. We had lots of moisture. It had been a dry spring, but we had got moisture in July, and away we went. The oat mixture was just about twice as good, and we strip grazed both of these, and the preference of the cows was to go after the oats, and they did not want to graze peas. Emma McGaw says to me she found the same thing, except that if you make the cows or leave the cows on peas and allow them a chance to get used to them, you can't keep them out of them after a while. And I do believe that. So there are different strokes for different folks, but generally we found that yes, this can work quite well for fall and or late summer and fall. Um, but we found that the winter cereal, after it had been grown in a mixture and walked over during the fall, um, did not survive nearly as well as the grazed winter cereal on its own. These things are picked up by producers, and an example is a family in the Claresholm area had gone through a really dry period of time during the early part of 2019. They had very little forage and had got or purchased some bobcat winter triticale, and they talked to me about how they could use it. So they planted it, and they were able to graze in the fall. It came through the winter with some winter kill, but then they felt there was sufficient enough that it could be harvested as silage. And where they had winter kill issues, they direct seeded over that with barley, and they harvested that mixture, the winter triticale and spring barley, as silage when they harvested the whole silage. They also told me that they had been able to ensure that crop with the AF&S crop insurance, and had been able to be paid for the parts that had winter killed. So they were quite happy with it. So how about a hay graze system? And this is one way to use another way, I suppose, of using the annual forage system kind of independently of perennial hay system. So we did run some experiments a few years ago where we compared the potential for stockpiling, in other words, harvesting hay from an old grass pasture, a meadowbrome alfalfa pasture, and an intercrop or mixture of oats and winter triticale. So all these were taken off as hay, and the economics here is based on selling that hay offsetting the cost. So the potential for offsetting the growth of the old grass pasture, which we talked about during that slide on soil moisture, is shown here, where both meadowbrome grass, alfalfa, and the oat winter triticale crop produced at least twice as much as that old pasture. Its quality was about the same as the meadowbrome alfalfa pasture. The beef yield, or beef gain in terms of kilograms per hectare or pounds per acre, was about the same or greater. And rate of gain was also quite high. So the replacement of that old pasture with, or substitution or supplementing that old grass pasture in a set of stocker animals work quite well. It is going to cost more per day, but the cost of doing this in a feedlot would be more, and may allow people to extend the grazing season and perhaps even keep more cows in total. Erick and I debated about whether to use this slide, but we thought that it kind of helped people think about where the cereals might fit in terms of mixtures, and what time of the year they could be used. So it will show the yield distributions on a percentage basis of when most of the growth occurs during the year. And this becomes important because you have to target a time of year when you want to increase that pasture to offset the perennial system. So as an example, barley is quite aggressive in the spring and produces most of its yield early on. I would say peaking probably as a pasture, because this is being grazed, peaking in about sometime after the boot stage. If we look at oats, oats is not as aggressive and also spreads out. Its tillers are less synchronous than barley and probably can get some regrowth from its secondary tillers. Italian ryegrass, which we'll speak about later, is not competitive at all early with the cereals, partly because it can spread out its growth distribution into the whole summer, as does winter cereals. So sometimes winter cereals and Italian ryegrass are quite useful in intercropping programs. If we plant our fall seeded winter cereal in the fall, you just get a little bump of production that isn't much use to you, but it could be of some use the following spring, providing some really early grazing that we're talking about. But most studies show that that early grazing by the winter cereal is only going to be for 2 to 3 weeks. So this brings us into a discussion about intercropping or cropping simple mixtures, and it also provides some lessons, I think, of how to build multi-species mixtures. And that is when crops, do the crops that you have or species that you have in the mix accomplish what you want, and are they complementary in their growth? So this this is a distribution in terms of kilograms per hectare and not percentage, but you can see that if we look at the intercrop compared to the double crop, the intercrop spring cereal produced its peak growth during the early part of the year, like we said. Because the intercrop is planted near the same time, or the winter cereal is planted at about the same time as the spring cereal, and it's not as aggressive in its growth. It peaks its growth at a later time of the year. So if you're grazing over this period of time, ultimately the spring cereal will go out and the winter cereal will take over and yield more in total. Alternatively, there are some areas in the province which can double crop. Now, in terms of silage production, this is an occurrence that happens quite a lot in Feedlot Alley, where a winter cereal is grown, taken off as silage, and then because there are enough heat units, you can get a barley crop put in, sometimes 2 crops of barley. In this case, what we're doing is looking at that as a practice for pasture. So what we're doing is planting the winter cereal after complete graze off or haying off of the spring cereal. The difference is the winter cereal does not, in a double crop, does not get to have as large a plants at the same time as the intercrop does. So the growth rate at the time when you need to take over the growing season is just not there. So it's in a short season environment, it doesn't work quite as well as the intercrop. So that brings us to a couple of examples of intercropping that we have in the Living Lab program. So what we did, quite a bit of the intercropping work that I did in forages started in the 1980s and has continued on some of the principles. But times have changed, and we have some different technologies now that we can use for intercropping that work quite well. Where we see some inter-row growth of a secondary species that will grow later or in the next year, like winter triticale, or in the case of Susan Heather, Italian ryegrass. So this is Derek Friend's farm, and he was able to plant spring wheat, and then because of his accuracy of GPS seeding, he could plant winter triticale between the rows of the wheat. So Erick talked about light penetration into the mixture, and you can see that there's space between these rows. Now the rows are probably fairly close to over 15 centimeters. So at least there was lots of light coming down between those wheat rows, and the winter cereal got enough light to survive very well. So the winter cereal, which quite surprised me, made it through the summer and over the winter. I believe he did graze it in the fall. There probably wasn't much winter triticale to graze, but it made it through. There was complete drought the next year, and he didn't add any extra fertilizer, and he did get, without very few inputs off this, about 20 bushels to the acre of triticale. In a strictly forage example, Susan Heather chose for her topic intercropping Italian ryegrass to be grazed later in the year after wheat and barley silage production. So she has done this for 3 years successfully. And I think she is listening, and she can answer some questions about this later on. So in early August, she would harvest silage. And then, because she had planted in the first year, she broadcast about 16 pounds of, or 14 pounds of Italian ryegrass. And with irrigation and so on, it survived and continued to grow. And about the 1st of December, she started to graze. Now, the growth continued until the 1st of October. It didn't grow at all in November, but then she started to graze it and grazed it in December and January. So this is what the Italian ryegrass regrowth looked like in 2024 after about 6 weeks of growth. So what she got out of this, and our target was 2,000 kilograms of dry matter of Italian ryegrass in the fall, and to be able to graze it afterwards. So that was the goal. So here are the results. So in the monocrop that she had a silage monocrop, and it was variable. So interesting thing here, each year, in 1 year, the monocrop was greater than the intercrop. This is for silage yield and 1 year, the intercrop would be greater. So that's okay for me, because what it meant was that the Italian ryegrass was not interfering with the growth of the wheat or barley. So it wasn't really diminishing the silage yield. Then we got different amounts of ryegrass growth. And when we added the growth of the ryegrass, or the dry matter production of the regrowth, to the silage, we always had significantly more. Real interest is the fact that when she did it the first time, she ended up with 1,500 kilograms of Italian ryegrass. By the time she finished, she had 4,000 kilograms of Italian ryegrass in 2025. Our goal was 2,000, which was about here. And our goal was 2,000 because we felt we had to exceed 2,000 kilograms of ryegrass above ground to get much carbon sequestration at all. But we got 4,000, so it will be interesting to see how this goes. The cherry on the top of that work is that what Susan really, really was after was some extra grazing for cows, where she would not have to feed them in a feeding site or conserve feed. So in December of 2023-24, she grazed for 60 days with varying numbers of cows. In 2023, she got 50 cow days an acre, or 135 cow days per hectare. In 24 was 68 cow days, 168 cow days per hectare. This year, she will get more, maybe twice that much, we'll see. So if each cow grazed on the ryegrass cost each day $2, the savings over 60 days per cow is $120 a cow. That's because Susan tells me to put in the feedlot in southern Alberta, the cow would cost $4.25. So we sawed it off for easy calculation at $4. So 220 cows, which she put on her acres, saved her $26,000, 400 a day. And she thought today, when I talked to her, that was pretty good. So we're coming to the end here. And because we have given talks, or I've given talks many places about corn grazing and swath grazing, we're going to just be quite abbreviated here. But we know that this is an option for late season grazing, and we may do our swath grazing earlier than the corn grazing, but we have some ideas of how to do this. And there are some new ideas which people are using, like attempting to grow some crops between corn rows, and sometimes that's successful and some not. And Emma McGaw has some information on that, and so do a few others. Long story short, Erick twisted my arm, and we did put these slides in, and from this study that we published, basically, oats yield more than stockpile grass, therefore, the carrying capacity is higher. But because we've paid for some of the cost of the stockpiled grass with hay production, just like Susan did with her silage production and her ryegrass, the stockpile grass is quite inexpensive. Also, the stockpile grass had a very high quality, and we would imagine that that's what we would have with the Italian ryegrass. So high yield and high carrying capacity reduces the cost, except in the case of stockpile grass, but it brought the cost of the daily cost of swathed oats down to at least 50% of feeding in a pen. If we had grazed corn, corn would have cost twice as much to grow, and we would have had to add a much higher yield than we had with oats, and that does occur. And we can come close to the oat cost. So going back here, and we look at the body condition score of the cows, we see because of high quality, we improve condition score considerably. Corn would do about the same as a stockpiled grass compared to the oat. So that finishes where we want to be with our talk, and we'll be able to start our discussion. Our take home, Erick and I agonized over this a lot, turns out to be quite close to what we started out with, and it is annual forages should be flexible, innovative parts of the existing perennial system. So we're not getting rid of perennial forage production for beef cattle, but we do think that there are opportunities to innovate with annual forages and make our systems more efficient. So thank you, Adrian. I think Erick and I are ready for questions, and I think Susan may be willing to answer some questions as well.
Awesome. Thank you so much, Vern and Erick. And yep, Susan is here, or she was. Let me see. Yep, she's still here. Susan, I'm going to allow you to talk. Do you want to share your perspectives at all? Not to put you on the spot, but to put you on the spot.
I really actually enjoyed this project, and we did, as Vern said, we did succeed with what our goal was. So we've really increased where we lacked pasture, so that fall winter time frame, and we have been able to push it out a little bit, definitely into winter, I guess, closer to calving, which was our goal all along. And yeah, it's worked very, very well for us.
So you're going to continue to do it?
Yeah, our biggest struggle now is to find a rotation. And we're kind of working on that this year a little bit to see if we do have some different pivots we can work on. It's just having the cows in different spots that we probably don't want them at that time of the year, but we'll work through that.
Fair. And I think, Susan, with your project especially, there's the impact on the ground itself, right? That you've seen a change in the soil health?
Yes. Yeah, we're really happy with that. So with the silage that would come off in August on our old system, that ground's just kind of left empty and barren for months. And now that there's something growing there, it's held the soil, and we aren't having any soil blowing. I feel like the ground's a little bit softer. Mm-hmm. And it's just nice. It's growing a better crop than what it ever had grown before.
Susan, could you pick up a little bit on how you changed your seeding system and how you think that worked?
With the Italian ryegrass?
Yes.
So the first year we'd always planned to use a seed drill with the Italian ryegrass. The first year after we seeded the main crop, we had a delay. So we were about 9 days after seeding. So we'd already had germination on the main crop. So we broadcast and rolled the Italian ryegrass on, which worked better than I thought it was going to. But then the next year we planted it with the seed drill. And as you can see from Vern's numbers, it increased on what the stand establishment was on the Italian ryegrass. So using the seed drill right after seeding for us was definitely the best way to get establishment.
So what was the biggest challenge you had getting this done?
Oh, I would say, like, if you were in a dryland situation, water would be your biggest challenge. With us, we are irrigated, so we do have a benefit there. On years where it didn't rain, having enough water for the project for what we're allowed to put on is probably still the limiting factor. And then there's a little bit of weed control issues that we're starting to see. You can't spray for wild oats with the Italian ryegrass, so I can see over the long term that becoming a concern. But if you were able to get a proper rotation, I think that would take care of it.
That makes sense. And just a reminder to everyone else, if you have questions for Vern, Erick, or Susan, now that we've got her on too, pop them into the chat or into the Q&A. I guess my question for Vern and Erick is for someone who maybe has followed a traditional cow feeding pattern and they're starting to consider adding annuals. What do you think is the first step or the baby step to take in that direction?
Well, I'll tell you a story.
Sounds
and the
good.
story is, when I was in high school, my dad decided to grow corn. Except he didn't have any way to harvest the corn. And to his surprise, it grew well. And he decided, or I left the gate open for cows to get to the field. And lo and behold, they were grazing corn. And he noticed they didn't come back in. And so he just left them out there to graze. And they grazed corn all winter. And the only thing he did wrong was he stopped grazing corn because he thought that he should be harvesting it for silage or combining it. So I think how you have to start, and that fitted our local system extremely well. So I think what Erick and I are saying is, don't do what we do and just go out there and run experiments that are planned. Step back and look at your system and see where you can make facility wise and forage wise work for you. Think about where the weak spots in your system are. Like, are you always running out of forage during midsummer? Or is it having to purchase hay in the fall? People tell me they are able to stay in cattle because of different aspects of this, whether it's grazing corn, swath grazing, or, I don't know, perhaps having cover crop pasture. It is, if you think of it solely as a bailout in times of crisis, then you're probably not going to take the best advantage of it. If you plan it and use it to, yes, plug holes, but also use it as a piece of a puzzle that will fill out your 306, not your 365 grazing season, but your 365 cow feeding system. If you look at it that way, then the answer will come to you. And then you have to try it. The other thing I would say is, surveys occur and people look at different aspects of how profitable a particular practice is at first. The reason that I said you have to have a target of 2,000 kilograms per acre or 2,000 pounds of ryegrass an acre or 100 grazing days these things have to have a significant impact in some way on your cow-calf system. So the significant way may well be to fill in a gap while you're combining, because you can't keep your cows grazing in the perennial field. It means they don't have enough forage. So you have to allocate enough land, going back to my slide about enough perennial pasture of different sorts for 100 cows. Well, you kind of have to figure out how much annual forage you need in that graph in terms of acres to fill all the gaps you need in your 365-day feeding system. So that might be partly green feed and it might be partly pastured. And don't fixate on one species. Think about how the different options that you might have. So that's a pretty complicated answer for a pretty simple question, Adrian. But I think forming a plan based on the capabilities of different species and your physical facilities that you have. That way you'll come up with the best answer. There isn't one specific answer, like everybody should go out and swath graze, everybody should go out and grow corn, everybody should go out and grow sun hemp. Use each of those options to their the best benefit you can get from them.
So, Vern, what year would that have been that you were corn grazing?
It was 60s.
There you go. So I feel like we've just heard that the very first corn grazing in Alberta occurred in the 60s.
Oh, it wasn't in Alberta.
Oh, it wasn't. Okay.
No.
Well done, Vern.
No, I missed that record.
Very early adoption.
Very early.
Eric, do you have anything you want to add to that?
Well, my father was an innovator. What can I say? He just didn't realize it.
Well, or you were because you left the gate open, one of the two.
No, I don't think I have anything else to add to that answer. I would just say like yes, try to fill the gaps, right? So you need to identify the gaps and see what fits in those gaps.
Awesome. Thank you. Susan, do you have anything that you want to chime in with?
Notice, don't be afraid to try things, I think is the most important thing, and be realistic about your own area and what it can produce.
Perfect. So I'm not seeing any other questions. I want to thank Vern and Eric and Susan, as well as Christine, for spending their evening with us. And thank you to everyone who came to the webinar. We look forward to seeing you again in 2026. Check out what events we have coming up. Eric and Vern are going to be talking about overseeding on February 18th, lessons learned in forage rejuvenation. So make sure to sign up for that one so that we can talk more about overseeding and how to continue to improve your pastures and your cow production.
Yes,
So
and I want to say Eric and I had a blast. Right, Eric?
Good.
Yes, it did.
Awesome.
Yes, it was very good, very great experience. Yeah.
Perfect. Thanks, everyone. Happy
Thank you,
night,
everyone.
and we'll see you in 2026. Thank you.
Thank you, everyone.
Thank you.
Thanks, everyone.